Hello, hello, hi everyone, hello. Am I audible to you all? Please let me know. Meanwhile, I will get my charger. Hello, MacDon. So, am I audible to you all? Okay, just a pupil said yes. Hopefully, you will become specialist soon. Okay. So, hi everyone. My name is Pradyumn, and today we will be discussing the solutions to the first four problems of today's CF round, which was Division 2. But before we start, I will tell you about our courses here at TLE Eliminators. So, if you are someone who is stuck at solving just one or two problems per contest, then our self paced courses are exactly what you need. Okay, so we have divided the content into four different levels so that you can start from wherever you are: beginner, pre intermediate, intermediate, or advanced. Okay, each course features um, video lectures by experienced educators, practice problems with guided hints and video solutions that help you understand the why and not just the how. And we believe in helping you build real intuition. If you need more help, you will get instant doubt support from our top rated mentors so that you are never left stuck. And beyond learning, you will enjoy leaderboards, gamified progress tracking, internal contests, and PCDs to keep you consistent. Pick the level that fits your goals and start learning today. And if you want to know at which level is best suited for you, then you can check out this video to understand how to choose the level. And if you are still not sure, then you can look at the video for that specific level, which tells you about the prerequisites, outcome, difficulty, and topics. All right. So let's get started now. So this was today's contest. Okay. So the problem A was suspension. A game is being played which initially consists of n players. On fouls, the referee is allowed to award yellow and red cards. The total number of yellow cards is Y and red cards are awarded to players is known for the game. There are two ways a player can get suspended: receiving a red card or receiving two yellow cards. Once a player is suspended, they are removed from the game and can't receive any more cards. Determine the maximum number of players suspended from the game possible. Okay, so they are saying that, okay, as you know, in a football match, um, you can like either get a yellow card or a red card, right? So as soon as you get a red card, you will get suspended, right? But if you get a yellow card, then that's like a first warning. And then if you get one more yellow card, then you will get suspended. Okay. And after a yellow, if you get a red, then also you get suspended, of course. Because getting a red means suspension and getting two yellows means suspension, right? So each person will only get a card at most two times, like either a yellow yellow or a yellow red, or he will just get a red on the first position, or he won't get any cards, right? There are just four possibilities for each person. So we want to determine, like we have been given that how many cards, like the total number of different cards, like the yellow and red cards that they had awarded to each player, and we have to determine that what is the um, actual like maximum number of players that were suspended from the game, like the different possibilities. Out of those possibilities, what is the maximum number of players possible which are suspended? Okay, so let's look at some samples. And yeah, they have given the number of players as well, right? N. So let's say we have 3, 1, and 2. Like there were three players, and there were um, Y and R. So one yellow card and two red cards. So three players, then one yellow card and two red cards. So it might happen that okay, this person got a yellow card and then he got a red card, so he got suspended. And this person got another red card, so he got suspended. So two persons got suspended. Okay, that is what can happen. And like you cannot suspend three persons. In this case, all three of them cannot have been suspended because two red card means like two red card means at most two persons would have been suspended. So two persons, and then you have only left one yellow card, and you cannot suspend someone with that. So the answer is two. Okay. Then let's say we have 6 and 0. That is, we have four players, one, two, three, four, and we have six yellow cards. So what we can do is either we can say that okay, these two got two yellows and these two got one yellow each, right? So in that case, both of these players would be suspended. But we can also say that maybe this player got two yellows as well, and this player did not get any cards. So in this case, three players are suspended, right? So the answer is three. So basically, the method is that first of all, you can just give the red cards to all the people. Like, let's say we have four people and we have two red cards and four, let's say five or let's say six yellow cards. Okay, two red cards and six yellow cards. So first of all, you will give the red card to each person. So the two red cards are gone, and these two have been suspended. Okay. Then what you can do is just give the remaining yellow cards to each person. So give this one two yellow cards and give this one also two yellow cards, right? So that's how all of these four are suspended. But of course, like you also have two yellow cards remaining, so you can assume that this person was initially given one yellow, and then he was given a red, and same for this, he was initially given a yellow and then a red. But the number of eliminations is four only, right? So in general, what you can say is like if you have R red cards and Y yellow cards, then you can say that the number of people is R plus Y upon 2 ka GIF. Like Y upon 2 ka GIF is that how many players you can give two yellow cards, right? But in this case, as you can see, if you apply this formula, it will get the wrong answer. Like here, R is 2, so 2 plus 6 by 3 ka GIF. So you're getting 5, right? But what is the flaw? The flaw is that actually we cannot give two yellow cards each to, sorry, 6 by 2. Two yellow cards each to three persons. Like this term of 6 by 2 is coming out to be 3, which means that we have eliminated three people using yellow cards only, right? But that would mean like that can't happen, right? Because we have only four players in total. Right. That's why we would have to give the remaining two yellow cards to already eliminated players. Like we have to give the yellow cards to these two. So actually, what we can simply do is take the minimum with n. Like we have the capacity to eliminate five people, but we have only four people. So we will take the minimum of 5 comma 4. So you can just evaluate this expression and take the minimum with n. So min of r plus y by 2 comma n. This is the answer. Okay. So I hope this might be clear. Just let me know if there's any doubts. R plus y by 2 or n. The minimum of both of these. Okay. So okay, I'll show the code. I mean, this is the code. There is nothing in the code. NYR, C in NYR, C out min of n comma y by 2 plus r. Right. Okay. I would get a plus 100. Yeah, probably. Like today, finally, after a long time, I got a good contest. Let's see what is my updated delta. Actually, the contest felt pretty easy to me today. I don't know why, but it did. I'm getting plus 90. Anyways, so this was A. Okay. So let's move on to B now. Split. You are given a sequence A containing two n integers. Let f of B denote the number of distinct elements with an odd number of occurrences in a sequence B. You need to split the given array into two disjoint subsequences P and Q, each of size n, such that f of plus f of Q is maximized. Output the maximum value. A sequence A is a subsequence of sequence B if A can be obtained by B from deletion of several elements from arbitrary positions. So what they are saying is we have to like we have an array A, okay, or let's say for an array B of length n, let's say B1, B2, B3 up to Bn, they have defined the f of B as the number of elements, the number of elements with odd frequency, right? So, for example, let's say in this one 414154, 414154, the frequency of 4 is 3, frequency of 1 is 2, and frequency of 5 is 1. So as you can see, this 4 and 5, they are having odd frequency, and so the f of this array is 2 because there are two elements which are having an odd frequency 4 and 5, right? So f of b is 2. Now we have to, like, we have been given the array A, and we have to split this array into B and C, okay, such that each element is in either B or in C, right? And both of them has to be of length n, okay, and the value of f of B plus f of C has to be maximized, okay. All right. So basically, let's just say that in array A, like the array A is given, okay, in the input A1, A2, A3 up to AN. Okay. Now let's say it has some k distinct elements. That is, let's say that an element x1, it appears y1 number of times. Okay. So like there's an element x1 in the array which appears y1 number of times. Then there's an element x2 which appears y2 number of times. And like there are basically k distinct elements. So there's an xk which appears yk number of times. Okay. All right. Now let's say um, we take this element. Okay, so first of all, what is the, like if I ask you what is f of a, it doesn't really matter much, but f of a is basically the number of i's, the number of I between 1 to k, such that y of I is odd. Like that is equal to f of a. If in my array A there are y1 instances of x1, y2 instances of x2, and like there are k distinct elements and yk instances of xk, then f of a is basically the number of elements, like the number of indices such that the frequency is odd, right? So now let's look at some a particular value, okay, like let's say we have x1 comma y1. In the array A, we have this number x1 and its frequency is y1, right? So we have to distribute this x1 into the two arrays B and C, right? That is, I have y1 instances of this element and I have to like insert them into B and C. Okay. So what I can do is like basically I have to distribute all of them, right? So let's say in the to the array B, I give z1 elements, like I give z1 instances of x1, and to B, sorry, to C I give w1 instances of x1. That is, y1 is equal to z1 plus w1. Like let's say I have an array A which has 1 4 times and some other elements. So it has 4 ones. Then to B, I can give 3 ones. So in that case, Z1 would be, so here Y1 is 4. So either I can give Z1 equal to 3, W1 equal to 1, or I can give, let's say, Z1 equal to 2 and W1 equal to 2, or something like that, right? So basically, for every distinct element, xi, yi, I have to split yi into 2. Like I can give zi to the array B and wi to the array C in such a way that yi should be equal to zi plus wi, right? And also the sum of like the sum of these numbers, basically z1 plus z2 up to zk, that is the number of elements in the array B, right? That should be equal to n. And same for C, that is w1 plus w2 up to wk should be equal to n, right? That is the length of both the arrays should be equal to, should add up to n, right? So that means we have to more or less divide each element equally. Like I will try to divide, will try to divide each element more or less equally. Okay. So now, let's say we have an odd number of occurrences in the original array. Like let's say I have the array A and I have one 5 times. Okay, right. So I have one occurring 5 times and then some other elements. All right. So when I divide it into B and C, so into B and C, let's say I give B x once and C y once. So that would mean that x plus y equal to 5, right? And here 5 is an odd number, correct? 5 is an odd number. So um, either x can be even and y can be odd, or x can be odd, y can be even, right? So if this is the case that x is even, y is odd, then in f of b, like I want to find out the value of f of b plus f of c, right? I want to maximize its value. So in fb plus fc, so if this is the case that x is even, y is odd, then 1 will not be counted in FB, but it will be counted in FC. And if this is the case that x is odd and y is even, then the element 1 would be counted in f of b, but not in f of c. Because we are counting the elements with odd number of occurrences, right? So in either ways, this value of 1, like this element 1, will increase, like will contribute a value of 1 to this sum. Like whatever we distribute the element 1, like these 5 elements, in whatever way we distribute them, they will always contribute an answer of 1 to my final answer. Okay. Like for example, if I have 5 ones and if I give B 3 ones and C 2 ones. Okay. then I would like while finding out f of b, I would count this one, but f of c mein this won't be counted. So this one is contributing a total of like this one, the element one is contributing a total of one to my final sum, right? And no matter the way I distribute those ones, okay. So what I'll try to do is I will try to distribute them evenly, okay. So it's like I will try to distribute them um, like equally more or less. Basically, if I have five ones, then I will give three to B and two to C, right? And that will ensure that like I have more or less equal number of elements in both of the arrays. Now, guys, one more thing to notice is that okay, let's say I have like x1 y1 x2 y2 up to xk yk. So let's say that some yi are odd, right? And some are even. So I just talked about the odd yi, right? So whatever elements are there with odd frequency, it doesn't matter how we divide them because in the end, they will end up with a contribution of 1 in our value of f of b plus f of c, right? But I can actually say something about the odd elements. Okay. Like, first of all, we know that this array length is 2n, right? The length of array A in the input is 2n, right? That means the sum of all frequencies y1 plus y2 plus up to yk, this would be equal to 2n, right? So actually, so basically 2n is an even number, right? 2n is an even number. So in this sum, there are some yi's which are odd and some yi's which are even, right? So my point is, um, there are like there have to be an even number, an even number of odd yi. Okay, like since I want the RHS to be even, right? And on the left hand side there is a sum containing even and odd terms. So of course, the even terms don't change the parity, right? And the odd terms, if they are even in number, then their sum would be even. And if there are odd numbers, if there are odd number of odd numbers, then their sum would be odd. For example, if I have 1 plus 3 plus 4 plus 5, so there are three odd numbers, so definitely sum cannot be equal to even, right? But if there are four odd numbers, 1 plus 3 plus 4 plus 5 plus 3, so 1, 3, 5 and 3, there are four odd numbers, so the sum can be equal to even, right? So my point is that since our sum is 2n of these y1 to yk, therefore the number of odd occurring elements is even. Okay, there have to be an even number of odd yi, or I can say that there have to be an even number of elements with odd frequency. Okay, so if we consider all the elements with odd frequency, we can actually pair them up. That's what even means, right? If there's an even number of odd occurring elements, we can make pairs of them, right? Like let's say I have 3 which occurs 5 times, 5 which occurs 7 times, 4 which occurs 3 times, and 10 which occurs 11 times. Okay, then actually, so there are 4, there are even number of them. So let's say I pair these two, and then I pair these two, right? And what we know is, in no matter what way we distribute these numbers, they will always contribute 1 to our final answer, right? So we will try to distribute them in like half and half. So for this 3, like I have this array B and C, right? So I will give B uh, three threes and C two threes. Like this 5 I'll split into 3 plus 2, right? But now B has one extra element. So in this pair, the second number is 4, right? Which occurs 3 times. So I will split this 3 into 1 plus 2. And so I'll give C one more extra element. So 4, 4, and here 4 comes. So in this way, the length of B and C remains equal. And since I'm able to pair all the odd occurring elements, I can always do this. Okay. So basically, I don't need to worry about the odd occurring elements. I don't need to worry about the odd occurring elements. Right. That is the thing. Because I can simply pair them up and I can split them very easily into B and C such that there's an equal number of elements in both B and C. Right. So until here, is it clear, guys? That the odd frequency elements I can distribute very easily. Okay. So any doubts until here? Rating, you can check on C list. But okay, I'm assuming that there are no doubts until this part. So let's move ahead. Okay, until here, I just concluded this that I don't need to worry about the odd occurring elements. Okay, like we can evenly distribute them, and they will always contribute one to the answer, plus one to the answer. Okay, but what about the even occurring elements? Even occurring elements. Okay, so let's say that I have an element, let's say 4, which occurs 6 times. Okay, so 4, 4, 4, 4, 4, 4, right? So what I can do is I can simply give B 3 fours, so 4, 4, 4, and C 3 fours, 4, 4, 4, right? So in this case, my 4 will appear in both f of B and f of C as well. So in f of B also my 4 will contribute a 1, and f of C also 4 will contribute a 1. So in total, the 4 will contribute 2 to the final answer. And this does not still change the length of B and C. That is, the length of B and C will still remain equal to each other because I am adding equal number of elements to both of them, right? But actually, this is the case where 6 by 2 is odd, right? That's why it worked. Like, even though 4 had an even number of elements, like the frequency of 4 was even, but um, frequency by 2, which is 3, this value was odd. So we could give 3 values to each array and it satisfies. Like, it is odd, so it is counted in both f of b and f of c. So that's why we can do this. But what if this 4 appeared an even number of times and the frequency upon 2 is also even? Like if we divide it evenly, then we won't get any profit. Like let's say I have 4 number of 4s. I have 4 4s, let's say, in my array A. Okay. Then if I divide it equally into B and C, or let's say I have, okay, yeah, I have 4 4s. So if I divide it equally into B and C, then it will get 2 2s, like 2 4s in each array, right? So the frequency of this number is even in both this array. in both arrays. So f of b plus f of c would turn out to be like, in both of these terms, the contribution of this element 4 is turning out to be 0. Okay. So actually we definitely can do better than that. We can definitely do better than that. That is, let's say we split it into 3 and 1. Like we give 3 fours here and 1 4 here. Right. So in that case, in both the arrays, we get a contribution of 1 and 1, right? But now the problem is that there is an imbalance. That is, there are like 3 fours here, but only 1 4 here. So the length of B is more than C. That is, the length of B is 2 more than C now. The delta is 2. Like between B and C, the delta has now become 2, right? So actually, we'll have to find another element which is having an even frequency and whose frequency by it is also even, and we have to counteract the thing that we did right now. Like let's say we had an array A which had four number of fours, okay, and let's say eight number of sixes, okay. So I have four fours and eight sixes. So let's say in B and C, I give like, in B I give three fours and in C I give one four. So now the length of this B is two extra, right? So now to counteract that, I can give less number of sixes to this B. Like see, the frequency of six is eight, right? And eight by four, sorry, eight by two is four. So I have to, like, ideally I would divide it into four and four. But since it is even, I won't do that. Instead, I'll divide it into 3 and 5. Like, I will increase this by 1 and decrease this by 1. So 3 I will give to B and 5 I will give to C so that it gets balanced out. So 6, 6, 6 and 5 sixes here. Right. So in this way, we can balance out the length of B and C. Like by basically pairing this 4 with this 6. Right. But now the only problem is, what if I have an odd number of these kind of elements? Like the elements whose frequency, like let's say the elements whose frequency is even and whose frequency by 2 is also even. So we have to like balance them out like this. Like basically, let's say this 6. So 6 ka frequency is 8, which is even, and whose by 2 is 4, which is also even. So instead of 4 and 4, we have to do 3 and 5. So we have to make an imbalance of 2, right? So if the number of such elements is odd, like here in this input, in the array A, I had two such elements, 4 and 6, right? But what if I have, so okay, I just paired them, right? Like this 4 I broke into 3 plus 1, and this 6 I broke into 3 plus 5. Like basically, this 4, instead of 2 and 2, I broke into 3 and 1. That is, to B I gave 1 extra, and to C I gave 1 less. And for this 6, instead of 4 plus 4, I gave this B 1 less and C 1 extra. So in the end, this total becomes equal. Like for the length of this B and C remain equal after doing this. But what if I have an odd number of these? Like let's say I have 4 4 4 4, 6 6 6 6, and 8 8 8 8. Right? Then what can you do? Like in that case, what you can do is, let's say you give three fours and one four to C, three fours to B and one four to C, and then you can compensate with this 6. That is 1 6 to the B and three sixes to the C. But now you are left with this, like just this thing, four eights. So you'll have to divide it into equal parts, and so this 8 will not contribute to the answer. Like in both f of b and f of c, the contribution of this would be 0. The contribution of 8 would be 0. Because if you didn't do that, like if you kind of did like this, that you gave 3 to this and 1 to this, then the length would be imbalanced and you won't be able to balance it unless there is one condition, like unless you have odd numbers. Okay, like let's say this was the array, and in addition to that you had an odd number of fives as well, like you have an element 5 which appears 5 times. And also, of course, you cannot have an odd number of odd elements, so you cannot have just a single odd frequency element. So let's say you have this 3 as well, you have this 3 as well, which appears an odd number of times. So this is the input. So until now, what you have seen is you can simply place this 4s and 6s, like they can be paired up, right? And that is fine. And also you saw that this 555, like this can be paired up with this to compensate each other, like 5 5 5 5 5. So you are dividing this into 3 plus 2, right? And you'll divide this one into 1 plus 2. So 5 5 5 3, and here you will get 5 5, sorry, yeah, 5 5 3 3. Okay, so here this is the thing, and now you are left with this 8 right? So now ideally what you would want is 8 here and a single 8 right here, but this results in the mismatch of the length, right? So for that, actually you can just transfer any odd element from B to C. Like this 5 you can delete from B and insert into C. And why is that? Because we saw that for an odd frequency element, either we can divide it into even plus odd, or we can divide it into odd plus even. And in both the cases, the contribution of that element would be 1 only, right? So if you have any odd element, like odd frequency wala element, you can simply transfer it in order to maintain the balance. And in that way, this 8 would also have a contribution of 2, right? Otherwise, this 8 would have a contribution of 0. Like otherwise, you have no option. Like let's say if this odd elements were not there, okay, like this 5 and 3, the odd frequency elements were not there. You just had this input, then you had no other option. Like in that case, you would have no other option but to pair this 4 and this 6 to compensate for each other, like this, and then 8 you have to divide equally only. So that would make the frequency of both arrays even. So it would contribute 0 to the answer. So in this case, the final answer is 4, because this this 4 contains 2. Like this 4 contributes 2, and this 6 also contributes 2. So the answer is 4. So this is how you can find the answer. Like basically, if you have any one odd element, if you have any odd element, or I mean odd frequency element, then basically everything can be matched. EV, everything can be matched. And otherwise, the last multiple of 4 frequency, it will be left out. Okay. So I will show you the code, and after that I'll take some doubts if you have any. Okay. So in 10 C in n, then I multiply n by 2 because the array length is 2n. Okay. And then I'll take the input of the array. Then I'll make the frequency map. Okay. and then I will count the number of odd frequency elements. Right. Now, in the frequency map, if the frequency is odd, then it will contribute 1 to the answer, right? And I'll increment the count odd counter. Okay. Now, again, for like this was for the odd elements, odd frequency elements in the frequency map. Now, for the even frequency elements, if the like if y and 2 means the 2 to the power 1th bit is 0. Like if it is 1, sorry, that means the y by 2 is odd. Okay, like I'm just doing some bitwise magic here. Let's say 10010. This is an even number, right? But it's this bit is odd. So when you divide it by 2, like when you divide it by 2, it will become 1001, right? So it will become odd. So if I take the bitwise and with 2, that is 00010. If this bit is 1, it will turn out to be 2, that is 10. And if this bit was 0, it would turn out to be 0. So if this y and 2 is turning out to be non-zero, that means the value of y by 2 would be odd number, right? So in that case, it would contribute 2 to the answer. Like basically, if I have a 4 which appears 6 times, then I can divide it into two equal halves, and both of them are odd. So it will definitely contribute 2 to the answer. So answer is equals to 2, right? Otherwise, I am just incrementing a counter. Okay. Like ideally, it would contribute 2 to the answer unless there are like it would contribute 2 to the answer unless there is an unmatched pair and there are no odd frequency elements as well. Okay. So if count odd is less than 2, that is it is 0. Like count odd cannot be 1, right? If count odd cannot be an odd number, right? So if count odd is 0, then I will print ans plus 2 into count minus count mod 2. Like what is this count? Count is the uh, number of elements with frequency a multiple of 4. So if there is one element which is left out, then I have to subtract it. Like let's say there are three elements with frequency 4. Let's say 4444, 6666, and 8888. So for this test case, you can pair these up. That is 4, 4, 4, and 6, and like 4, 6, 6, and 6. So both of these contribute 2 to the answer, but this one is left out. So in this case, the count is equal to 3. And since it is odd, I'll subtract minus 1 from this because this one is left out. And they contribute 2 to the answer. Like this 4 contributes 2 to the answer, and 6 contributes 2 to the answer. So I will write 2 into count minus count mod 2. Okay. Otherwise, see out answer plus 2 into count. That is, if I have an odd number, like odd frequency element, then I can simply say that the answer is ans plus 2 into count. That is, every, like I can include this 8 as well. This 8 also will contribute 2 to my answer. That is, somehow I can give 3 eights here and 1 8 here. And I can simply transfer an odd element from B to C to balance it out. Okay, so every element in this array, like every distinct element, is contributing to an answer of 2. So the ans plus 2 into count. Okay, so in this case, count is 3, right? Okay, rating things have come. I got plus 80. Nice, that's cool. So, anyways, I hope this code is clear. Is this problem clear? Uh, Sportang, Spartang. Is it clear now? Everyone, is it clear? What are we doing exactly? Okay. Yesterday's problem B. Um, I don't remember what was that. Long long. Okay, the sum. Right, right. Even some grandmasters used int for the sum. That's a pretty common mistake. Like you should not have. You should avoid that. Anyways, let's move on to the C now. Um, so problem C was annoying game. You are given two integer arrays A and B, both of length n, and a total number of turns k. Alice and Bob play a game by taking turns modifying array A. Alice goes first. The game lasts exactly for k turns. On their turn, a player must choose an index I and perform one of the following operations: add, increase AI by BI, that is set AI to AI plus BI, or they can subtract, that is decrease AI by BI, that is set AI to AI minus BI. After the kth turn is complete, the final score is calculated as the maximum non-empty subarray sum of the modified array A. Alice's goal is to maximize the final score, while Bob's goal is to minimize the final score. Assuming both the players play optimally to achieve their respective goals, determine the final score. Okay, so like what they are saying is that um, the array A is given initially. There is an array A whose initial values are given. So A1, A2 up to AN, and an array B is given. Okay, B1, B2 up to Bn, and this array A has values both positive and negative, right? And this value, this B is always positive. Okay, so in one operation, Alice can basically choose any index I and set AI to AI plus BI, or like Alice can either add or she can subtract AI minus BI. That is set AI to AI minus BI. So both of them can actually do the same thing. That is on Alice's turn. Alice can do AI goes to AI plus BI for any I, and or she can do subtraction. And same as like same for Bob. Bob can also either add or he can subtract. Right. So the game will last for k turns. Okay, k turns. And turn means what? Like Alice doing one operation is one turn. Like let's say if k is 3, then Alice will play one turn, then Bob will play one turn, then Alice will play one turn, and the game will end. Okay. So after k turns, if both of them play optimally, then what is the maximum survival sum? Maximum survival sum. If Alice wants to maximize it and Bob wants to minimize it, like Alice wants to have the maximum possible MSS value and Bob wants to have the minimum possible MSS value. Okay, so the problem should be clear, I guess, right? Okay, so let's just think about what Alice and Bob are trying to do. Okay, so if you have the array A, you have the array A, right? So um, Alice will do something. Let's say array A is A1, A2, A3, A4. A5, A6, A7, and A8. So Alice will do something. Let's say to A4, she adds B4. Okay, first of all, Alice wants to maximize the subarray right? So of course, Alice won't subtract. Like Alice will never do a subtraction, right? Because that is never good for her. Like Alice will always add, right? So let's say to this element A4, she adds B4. Okay. So it becomes A4 plus B4. Okay. And the other elements stay the same, like A3, A2, A1, then A5, A6, A7, and A8. Right. So this is the final array after Alice does her thing. Right. Now actually what we can say is Alice will try to like make the sum large. Right. Like intuitively, we can say that the Alice will try to maximize the subarray sum, right? In this, that is, we can assume that let's say that for this array, the maximum subarray sum is from here to here. Okay, the maximum subarray sum is from A3 to A6, right? Then we can say that this B4 value is the largest among this 3 to 6. Okay, we can say that actually. Like if you think about it, what is my statement? My statement is, let's say that Alice increased this B4. Okay, and after doing that, in this new array, the maximum subarray sum is given by this subarray from A3 to A6. Okay, then I am saying like that. Then I am claiming that B4 is definitely greater than equal to B3, B5, and B6. That is, B4 must be the maximum out of these four numbers. And why is that? It is because if B4 was not the maximum of these four values, then Alice would have increased that instead. Like instead of increasing B4, Alice would have increased, let's say if A5 was larger, I mean, if B5 was larger, then instead of increasing B4, Alice would have increased B5. So A5 plus B5 would have been there. And in that case, like this subarray sum is larger than having this. Like initially, what is the sum? If Alice would have increased B4, then the sum is A3 plus A4 plus A5 plus A6 plus B4. Right? I just wrote A4 plus B4 like this. And instead of Alice increased B5 instead of B4, then it would be what? A3 plus A4 plus A5 plus A6 plus B5, right? So if B5 is greater than B4, then the final sum would be greater for B5. So Alice would have done that instead. But since Alice chose B4, that means that B4 is the highest value among all of these, right? Okay. So now my point is that Bob will definitely decrease this B4. Like now it is Bob's turn, right? Alice did something. Alice did something and made it A4 plus B4. Now it is Bob's turn, right? So now if let's say, so of course Bob will decrease something, right? One thing's pretty obvious that Bob will decrease something. So let's say that Bob decides to decrease something other than B4. Like from this subarray, Bob decides to decrease, let's say A6. So basically he changes this A6 to A6 minus B6, right? So now finally what's the sum? The sum has become A3 plus A4 plus B4 plus A5 plus A6 minus B6, right? So we can say it is A3 plus A4 plus A5 plus A6 plus b4 minus b6. And since this quantity is non-negative, like basically Alice did one turn, like what happened till now was Alice did one turn. Okay. Then Bob did one turn, and again it is turn of Alice now. And the sum is now this. Like initially it was just a3 plus a plus a5 plus a6, right? But now it is that plus some quantity, right? Some positive quantity or some non-negative quantity, right? So if Bob keeps this up, like if this strategy goes on moving, like if this strategy goes on, then the sum would keep increasing. Like in the next iteration, it would become twice into this, then thrice into this. So it is like it keeps increasing, right? So instead of that, what would Bob do is Bob would just decrease this b4. That is the best thing that he can do because b4 is the highest value, right? b4 is the highest value in this subarray. So if Bob did not decrease this b4, instead he decreased this b6, then finally Alice would get a better sum in the end, right? So definitely Bob would decrease this b4. Okay. So Alice made this a4 plus b4, but now Bob would decrease this b4 and make it again just a4, right? So after Bob's turn, again the array has become same, right? So now again Alice will do a4 plus b4, and then again Bob would subtract it, and this would keep happening, right? So if it is Bob's turn at the end, like if Bob's turn is last, then the array would stay the same. Okay. Otherwise, Alice would get one more extra turn, and he can get like or she can do anything she wants. Okay. So if k is even, then what will happen is Alice Bob, right? So Alice will do something, then Bob will undo it, then Alice will do the same thing, Bob will undo it, Alice will do the same thing, Bob will undo it, and finally the array stays the same. Okay. If k is even, then the array will stay the same. And if k is odd, then basically Alice gets one extra move. Let's say Alice, Bob, Alice, Bob, Alice. If k is 7, that is then this happens. So whatever Alice does, Bob will cancel out this. Like whatever Alice does, Bob will cancel it out. Then Alice does something, Bob cancels it out. Alice does something, Bob cancels out, and then Alice would do something, and that would persist. So basically, Alice gets one move. Basically, Alice gets one chance to add, like to change the array. Okay. So basically, Alice can choose any index I and add the value of bi. Okay. Only once, right? So she will add that value of bi, which gives her the maximum MSS value of the entire subarray. I mean, of the entire array. So if k is odd, then the array will stay the same, and so the answer would be the maximum subarray sum of that array. And if k is even, sorry, if k is even, then the array would stay the same, and the value would be maximum subarray sum, right? And if k is odd, then Alice gets one extra move. So we can say that she can just choose any index and increase it, and then whatever is the maximum subarray sum, that is the answer. So Alice will try to increase that element in such a way that the maximum subarray sum is maximized. So the problem boils down to finding that what is the that index, right? Okay. So until here, do you get it, guys? Until here, do you understand that in even case, the answer is just maximum sub sum, and in odd case, Alice can choose any index to increment by bi and find out the maximum sub sum in that case. Okay. So now, how do we find out that what is the maximum possible maximum sub sum if you are allowed to increase any element by once, like by bi? So how do we find that out? So basically, let's say that you are increasing some index I, right? Then, like basically, it was AI initially. It was initially AI. So by increasing it, you can make it AI plus BI. Okay. And so if you are increasing it, then of course in your maximum sub this will be contained, right? Otherwise, there is no point in increasing it. Okay. Like finally, whatever sub-array you are choosing as your maximum sub-array, like finally whatever sub-array you are choosing. Let's say if you are choosing this sub-array as your maximum sub-array, then you will definitely increase one of these three elements, right? To maximize your sum. Like here you have V7, here you have V8, and here you have V9. So you will definitely increase either B7 or B8 or B9. Whichever one is the highest, you will increase by that amount, right? So I can say that if you are increasing at index I, that is you are making this AI to AI plus BI, then definitely your maximum subarray contains this element. Okay. So like if you are changing this AI to AI plus BI, you just want to find out the maximum subarray sum containing this element. Okay. This is what the idea is, that if you want to check that if you increment an index I by this much amount, then you can just find out the maximum subarray containing this element, and you can write it like basically you will go until some amount, right, to the left, and you will go till some amount to the right. Okay. So basically you just want the maximum subarray ending at I minus 1 and the maximum subarray starting from I plus 1. Okay. And then you can just combine this value plus this value plus AI plus BI, right? And that would be your value if you increment at the index I. Like what you can simply find out is the maximum subarray ending at index I minus 1, and also the maximum subarray starting at index I plus 1. Okay. And that's how you can simply find out the maximum subarray Okay. Like, should I give an example? Let's give an example. Let's say 3 minus 1, 9 minus 5, 4. 3 minus 1, 9 minus 5, and 4. Okay. And let's say the incrementing factors are 1, 2, 3, 4, 5. Like the array B is 1, 2, 3, 4, 5. Array A is this. Okay. And let's say that I want to find out that if I increment at the index 3, then what is my um, Like then what is my final subarray sum? Okay. So if I increment at this index 3, then it becomes 9 plus 3, which is 12, right? So this element becomes 12. Then maximum prefix sum, like maximum prefix sum ending at the index I minus 1 is this, right? You can get 2 from here. And maximum suffix sum, it is 0 only. Like you will not take this minus 5, and you will not take this minus 5 plus 4 also, because it is minus 1. So you will take 0 from here. So in total it is 2 plus 12 plus 0, which is 14, right? So basically for each index I, you just have to store the maximum subarray sum ending at I, and also for each I you have to store the maximum subarray sum starting at I. And like this is what you store in Cadence algorithm, right? In Cadence algorithm, you basically store this only. Your dp of I stores the maximum subarray sum ending at I, right? So that is basically max of either you start a new subarray at I or you continue the previous one. So that would be the dp of I minus 1 plus a of I, right? This is how you can calculate your maximum subarray sum ending at index I. And if you want starting at index I, then you can simply do from the opposite direction. dp of I equals to max of ai or dp of I plus 1 plus ai. Okay. So this is how you can evaluate the maximum subarray sum acting at ending at I minus 1 or I plus 1. Okay. And then simply for every index, you can check that if you add bi to that index, then what is the maximum subarray sum that you will get. Okay. No, this will give TLE because applying Cadence algorithm would take O of n time. You can actually use segment tree. Like there is one segment tree which can update in log n time and give the maximum subarray sum. And actually that's what I used in the contest because I had the code already written. So I just copied it and I changed, like I checked every element. I updated every element and then I checked the maximum subarray sum and then I just took the maximum. Okay. So this is what the problem C look like. Do you guys understand? Any doubts? Anyone? If there are any doubts, then you can ask right now. How to do in prefix and suffix sum? Like in this problem, to solve it, you have to keep track of the Cadence algorithm values. Like let's say you have minus 5, then you have 10, then you have minus 11, then you have a 6, then 7, and then minus 10, and then 8. Okay. Then your dp value would be what? Like in dp, like my dp of I is storing the maximum subarray sum ending at I. Okay. So for the first element, the dp value is just minus 5 because only one subarray ends at this index, right? Then for this, the maximum subarray sum ending at this index is this one, right? Like there are two subarrays, either this one or this one. So the answer is this, right? Then for this element, the maximum subarray sum is minus 1, like basically this subarray, right? Then for this, the answer is 6. Then for this element, the answer is this subarray, so 13. Then for this, the answer is just this, so 3. And for this element, the answer is this subarray, which is 11. So basically, the DP of I stores that what is the maximum subarray sum ending at this index, right? So if let's say you want to increase this 7 right here, let's say you want to make it 11, okay, then what you will do is you will check the maximum subarray sum to the left of it, like ending at I minus 1, what is the maximum subarray sum? And to the right of it, starting at the index I plus 1, what is the maximum subarray sum? So this is the DP that you will keep from front, and the DP, like one more DP you will keep from back, the similar kind of DP. And basically, if it is DP1, let's say it is DP1, then you can say that your final maximum subarray sum value would be DP of I minus 1 plus AI plus BI plus DP of I plus 1. I mean DP1 of I plus 1. Okay. Alright. So I'll show the code. Actually, I did in segment tree. Like in this contest, I just solved this using segment tree. So you can do that if you know how to. But I'll show someone else's code because I did not use this approach. But it was a simpler one, so I explain that one. Okay. Sorry. C, right? So this was the code. Okay. So um, int nk, c in nk, vector of int a of n, take the input and take the input of bn, and dp. So dp is from left to right. Like dp of I is storing the maximum subarray sum ending at I. So dp of 0 is a of 0. Then from 1 to n, dp of I is max of dp of I minus 1 plus a of I, or like basically just continue the previous subarray or start a new subarray at this index, right? The maximum value. Now if k mod to equal to 0, so if k is even, then just print the maximum subarray sum, that is the maximum element in this dp array, right? Now if k is odd, then we will increment at every index and check. So for that we need this thing. We need this, that what is the dp value in the previous direction. So dp1 of like dp1 of n minus 1 is a of n minus 1, and from n minus 2 down to 0, we can say that dp1 of I is max of dp1 of I plus 1 plus a of I, or a of I, right? And this line is unnecessary. Like actually this is not very accurate. You can just write ll ans equal to 0, just initialize with some value, and then for every index we are doing core equals to dp of I minus 1 plus dp1 of I plus 1 plus ai plus bi. Okay. So ans equals to max of ans comma cur. Like for every index, you are finding out that if you increment it, like if you make it ai plus bi, then what is the maximum possible Savarius sum? It is dp of I minus 1 plus dp of I plus 1 plus ai plus bi, and you are taking the max of it over all the indexes. So finally, just print the answer. Okay. So I hope you understood this code as well. So I'll move on to the next one now. Problem D was pretty easy. Like I found it pretty easy, which was palindrome flipping. You are given two binary strings S and T, each of same length n. You are allowed to perform the following operation. Pick indices L and R such that substring L, R is a palindrome, and flip all the bits in substring L S L to R. The goal is to finally make S equal to T, performing any of the operations at most 2n times. Okay. And flipping का मतलब है कि like you can change all the zeros to the ones and ones to zeros. That is, let's say 101 becomes 010. Okay. So let's say like you have an example here 01011 01011 has to transform into 1 and 4 times 0. Okay. So you can like the operation that you can do is you can choose any palindrome, choose a palindrome substring. Okay. And um, basically flip it. And this has to be of length at least 2. The length of it should be at least 2, because if it was not that, you can simply choose any one length substring and it is always palindrome. So you can just flip it, right? That would be too easy, right? So the rule is that you have to choose a substring which is a palindrome of length at least 2, and then you can flip it, and that is one operation. Okay. And you have to convert the string s into string t. And if it is not possible, then you have to print -1. And you get 2n operations to do this. Okay. So here, let's say what you can simply do is they have given the answer also 1, 3, and 3, 5. So this 010, it is a palindrome. So you can convert this, like you can flip this. So 010 would become 101. So 10111. And then you can flip these three ones. 111, it is a palindrome. So it becomes this 10000. Right. So this is how the answer came in the first uh, test case. Okay. So how do we actually solve this problem? Let's try to think about that. So actually the construction is very simple. Like if I just move ahead with the construction, like I told you, if I just tell you what I did, then it would get over in 2 minutes and you would not get any insights from that. So I will tell you that what was my thought process. Okay. So actually what I thought was you can exploit one fact. What fact you can exploit? You can see that 00000. This string is a palindrome. Like any run of zeros, that is at least two zeros, or three zeros, or four zeros, or five zeros, or six zeros, all of them are palindromes. So you can flip them easily. So basically, you can choose any block of zeros in your binary string. You can choose any block of zeros. I mean, not of length 1. So length has to be at least 2, but you can choose any length at least 2 of contiguous zeros, and you can flip it, right? And same as 1, like same thing with 1, correct? So that is a pretty powerful thing to notice, right? Like basically, if you have some, let's say you have two zeros and then you have some other strings, something like this. Okay, so you have these two zeros in the middle. So now what you can do is you can simply choose this substring and you can flip it, right? So it becomes 1 1. Okay, then actually, so initially there were two zeros here, right? But now there are four ones here, right? So now you can flip these four ones as well, and it becomes four zeros, right? So there were four zeros here, but now there are six zeros. This is a block of six zeros, and you can flip all of it, and make them six ones, right? And now there are like 10 ones like this. So you can flip all of them and make 10 zeros. 0 0 0 0 0 0 0 0 0 0, and then there were 10 zeros here, but now there are 12 zeros like this, and so you can flip all of them to make them all ones. So 1 1 1 1 1 1 1 1 1 1 1 1, 12 ones, and then now you have 13 ones. You can flip the entire string and it becomes all zeros, right? So it is very easy to make this initial string into all zeros. So, like, what you can just do is find any two same digits, right? Like in the string, find a position I such that s of I is equal to s of I plus 1. Okay. So that would be your initial block. Like, as you can see, the 0 0 in the middle, I chose. Like here, I have these three ones, these two zeros, these two zeros. I can choose any of them. So let's say if I choose this. So initially, my range is this one, and I can basically keep expanding on both sides using the operations. So initially range is this. Now if I flip this, it becomes 1 1, and now there are four ones like this. So my range becomes bigger, right? And again I can flip this entire range and take this 2 0 as well. So my range would become even bigger, and that's how I can expand. And slowly and steadily, my entire string would become equal to all zeros, right? This is what I can simply do. I can convert my string into all zeros very simply by just finding an index which contains two elements which are same. Like s of I should be equal to s of I plus 1. I just have to find an index like that and start from there. Like start expanding from there. And that's how we can make all same zeros. Right? But now you might ask that that was not our problem, right? We had to convert s into t. Like I just told you how to convert s into all zeros, not s into t. Okay. So how do we convert s into t now? Like that's not the, like the question is not answered yet, right? But what I am telling to you is that just look at the operation very carefully. Okay. My point is that the operation is reversible. Like if you have a string 10100, and let's say you perform the operation on some l comma r. Okay, so it becomes 0 1 0 0 0. So you were able to perform this operation because this was palindrome, right? This l comma r substring was palindrome, so you were able to perform this, and it became 0 1 0, right? And the thing is that even after flipping, it is still a palindrome, right? So you can perform the operation again on it, l comma r, and it would give you the same string back. Like you would flip it again, and it would give you the same string back again, right? That is the entire point. That if you do this operation one more time, then it would give you the same string. Okay. So like my point is that let's say I know that this 10100, if I do let's say the operation 1 comma 3, I would get 0 1 0 0 0, right? And then if I do the operation 3 comma 5, then I would get 0 1 1 1 1. Then if I do operation 2 comma 5, then I would get 0 0 0 0 0. So if I know this, like if I know that by doing these three operations I can get to 0 0 0 0 0, then I also know that if I take 0 0 0 0 0 and if I do 2 comma 5 on this, then 3 comma 5 on the resulting array, and then 1 comma 3 on this thing, then I would reach back to this string. Okay, that's my point. That the operation given in this problem, it is reversible. Okay, so if I know a way to go from the string to 0 0 0, then actually I know a way to go from this string, sorry, to go from 0 0 0 to that string also. If I know a way to go from this string s to 0 0 0, then I can just reverse those operations. I can simply reverse those operations and I can reach the initial string from 0 0 0 0 0. So what I can simply do is I can convert the string s to all zeros, right? And also I can convert t to all zeros. Like I can get the recipe for converting s to all zeros and the recipe for t to all zeros. That is the operations that we need to do. And then I can simply reverse this operation list and then append it in front of this operation list. Like simply just convert s to this 0, convert s to this zeros, and then convert zeros back to t. So if we know how to convert t to zeros, then we can simply reverse the operations and convert 0 to t also, right? So you can simply write a function which takes in a string and tells you how to convert it all into zeros. And basically the algorithm that I told you, that just start from the middle and expand both sides. This would take you at most n operations, right? Because in each operation you are flipping at least one more bit, or like your active range is increasing by at least one, right? And finally it is n only, its length is n. So the operations cannot be more than n minus 1 in fact, because you start out with 2, or let's say n. Okay, so at most n operations will be taken to convert s into 0 0 0, and similarly at most n operations will be taken to convert t into 0 0 0. So at most 2n operations will be taken, and that is the limit, right? So that's how you can simply do this problem. Sorry. Okay, so do you all get this? Do you all understand this now, or is there any doubts? But yeah, there is one more edge case that I didn't talk about. I told you that you will start out with an index such that s of I is equal to s of I plus 1. That is, let's say these two zeros, or these three ones, or these two zeros, or something, right? But what if there is no such index? That is, your binary string looks like this: 1 0 1 0 1 0 1 0 1 0. So in this case, there is no such index which is the same. Then what will you do? Then actually you can perform one operation on 1 comma 3. Like 1 comma 3 would be either 101 or 010, right? So like your string would be either this or it would be this: 010101010, right? So you would perform the operation 1 comma 3. Okay, and so this would become what? 010, and now you have this duplet right here. Okay, so one operation is gone right here, and then n minus 1 more operations can be there. Okay, so at most n operations would be taken. So yeah, if initially your string looks like this, 101010101010, then you can simply do an operation on the first three elements. And since, because it is a palindrome also, right? 101 is a palindrome. Okay, so I hope you all got it. If you all have a doubt, then please let me know. I will wait for 30 seconds to answer any doubts, and then I will show the code. Okay, so I will show the code then. So in the code, I have this function which returns a vector of pair. Like it takes in a string and returns a vector of pair. That is the operations to make this string to zero. Okay. So first of all, I check if um, like I apply unique function on the string s, and if it remains the same, that means the string is of type 10101010. So first I'll do the operation 1 comma 3, like answer dot pushback 0 comma 2, because in zero indexing it is 0 comma 2. Okay, so and also I'll update the string, right? I'll update the first three indexes, like I'll flip them, si equal to 0 plus 1 minus si. Then I have two pointers, p1 and p2, which are my active range. Okay, so I'll find that index. If s of I equal to s of I plus 1, then p1 is I and p2 is I plus 1. So I'm just finding out that index which has the duplicate, right? And then I'll extend this p2 to the right, and like basically while p1 is not equal to 0 or p2 is not equal to n minus 1, I will do the operation, and I will extend, yeah, I'll do the operation and update this s also, and then I'll try to extend this p2 towards the right, p2 plus plus, and p1 towards the left, p1 minus minus, right? So I'll keep doing that while my active range is not the entire string. And also in the end, I'll check if it is all ones. Like it might happen that my active range is 0 to n minus 1, but it is all ones, not all zeros. So if it is all ones, then I will push back one more operation, which is 0 to n minus 1, right? And then I'll return the answer. So this function is helping me to convert this string s into all zeros, right? So um, yeah, I have string st, c in st. So I'll make 0 of s, like I'll make string s to 0 and store the operations in u. And I'll make 0 in t, that is um, the I'll make the string t to all zeros and store the operations in v. Okay, and then um, this is optimization. Like I don't think it's necessary, but if v dot back is equal to u dot back, basically what I'm doing is I'm printing u from left to right and v from right to left, right? So if I have the same operation on the end, then I will just delete that, because they will cancel out anyways, right? So I'm doing this, and then I'm just printing the operations. Like I'm just printing out the operations in u from left to right and in v from right to left. Okay. Yes. Correct. So I hope it is clear to everyone. And if it is clear to all, then I guess I will take your leave. Okay. So I guess you guys don't have any more doubts. So I will take your leave now, and I'll see you guys later. Bye, everyone. Good night. How do I think this good? I'm also shocked. Like today was a good day actually, after a long time. But yeah, good night.